Climate change is commonly associated with increased global temperatures. However, in the Pacific Islands, climate change is having two main impacts on water supplies. Firstly, it's altering rainfall patterns, resulting in decreasing precipitation in the Pacific Islands. And secondly, sea level rise is causing saltwater intrusion into groundwater, thus making the water not suitable for human use. Therefore, Team Slack aims to address the problem of strain on diminishing groundwater supplies in remote Pacific Island communities by diversifying water supply so that groundwater extraction becomes a last resort. As there is an abundance of salt water surrounding the Pacific Islands, we propose to introduce small-scale desalination to remote communities to supply safe and sustainable drinking water independent of groundwater. In particular, Team Slack is focusing on desalination techniques which can be done on an individual or household scale and use very little resources. In particular, we are interested in desalination which can be done using salt water and sunlight alone.
The solar desalination still must satisfy several requirements to be practical as a water source for remote communities. The WHO states that an adult needs a minimum of 7.5 litres per day for basic survival. Therefore, a still must convert at least this much drinking water from seawater each day, as well as be a manageable size. Any solar still design is limited by the materials and skills available to the inhabitants. We will present two potential still designs here, each using different materials. The first is a square-based pyramid solar still. The double layer of the base and the short sides are made of any available material, and the gap is insulated with sawdust. A thin sheet of metal, such as steel, is placed on the base, and a pyramid made of clear plastic or glass is placed on the top of the walls. The base is then filled with seawater, which is evaporated via solar radiation. The condensation flows down the inside of the pyramid and collects in output tubes going through the walls. This pure water is then collected and ready for drinking. Our other suggestion is the Elio Domestico, which is an open-source solar still made of a clay chamber, a metal lid, a plastic tube, and a collection tray. Seawater is poured into the main chamber and evaporates during the day. The steam travels down the pipe and condenses above the collection tray as pure water. Both of these designs require little technical knowledge and use tools widely available to the communities. The pyramid still produces approximately 3.3 litres per metre squared per day, and the Elio Domestico produces 10 litres per metre squared per day. For a family of 5 to survive entirely on a solar still, they would need a pyramid still with a width of 3.4 metres, or an Elio Domestico with a diameter of 2.2 metres, or multiple smaller stills.
We have suggested two different designs so that locals can use the materials most accessible to them, whether that be plastics, glass, or clay. Plastic is cheap and can be easily shipped from the mainland, while clay can be formed from natural materials on the islands, and lapidar pottery techniques have been circling in the Pacific since at least 800 BCE. These solutions are also very cost-effective. The clay design can be constructed from as little as 20 to 50 USD, and the pyramid for 80 to 100 USD. We have focused on smaller remote islands as the people there are typically most vulnerable. Their location means they are less likely to have access to funding and resources of the mainland. The low cost and simple designs mean they can be easily replicated. We propose to teach locals to create and repair these structures so that the technology can be easily scaled up or down with need. The knowledge could be passed down through generations so that it is sustainable over time. This education would also include information about why purely groundwater extraction is not feasible, so that locals can understand why the stills are an alternate option. Additionally, locals would learn where to dispose of brine in the most sustainable way. Given the low levels of brine created in the process, depositing it back into the ocean would make a negligible difference. In addition, the stills are fairly easy to use, meaning once a still is created, fresh water can be easily made and collected, even by children or the elderly. The clay also includes a basin specifically engineered to be placed over the head and carry water easily this way. We would consult with communities directly to find out where stills or collected fresh water should be placed and stored. Given the community-based system in these islands, it would likely be in the centre of the village so that it is easiest to access. But as the systems are highly portable, communities would be able to move them as necessary.
In summary, to help remote Pacific Island communities decrease their dependence on groundwater, we propose two solar still designs that the community can choose from based on the availability of materials and ease of use and maintenance. This solution is a cost-effective and adaptable method for decreasing strain on groundwater supplies and increasing water resilience into the future.
Thank you for watching. We hope you enjoyed the video.